Okay, welcome America, welcome India, and welcome Selena Gomez to the live studio recording of Precalculus Day 1 in Studio 202. So today we are going to move on in the same worksheet to problems 6 and 7. And right now the directions say find the domain of each function. And we just did a problem where we had a denominator. The numerator was x and the denominator was x squared minus 16. And we had to set our denominator equal to 0 to figure out what values that we couldn't put in for x, okay? And so now we're moving on to some radicals. And so we've got other problem areas here with these radicals, okay? In this problem, we just have a radical, number 6. And in problem 7, we have a radical, but we have a radical in the denominator, okay? And they're slight difference. So we talked about what happens when we have a denominator and we can't have that denominator equal 0, because if we have any number over 0, it's undefined, and then we have no point to plot. So we have to remove that x value that makes our denominator 0 from our domain. Well, we've got the same issue when we have radicals. So think about the graph of what a radical looks like back from algebra 2. So y equals the square root of x, okay? So it looks like this. If you the square root of 0, you can do. Square root of 0 is just 0, right? So if I put in 1, I get 1. The next value I'd like to probably put in after 1 would be a 4. Square root of 4 is 2. That's pretty easy to do. 2, 3, 4, 2. And then the next one would be 9, because the square root of 9 is 3. So you can kind of see the graph looks like this. Notice there are no negative values for x. I can't plot. If I plug in a -1 here for x, the square root of -1 is going to be imaginary and we can't plot it. So this domain for radical is x is greater than 0. Greater than or equal to 0, actually. We can include that 0. So what we can do here is we have to take what's under this radical and we have to set that greater than or equal to 0 and solve for what values can work under the radical. So I get 3x is greater than or equal to 12. Divide both sides by 3. I get x is greater than or equal to 4. And the way we're going to write that for domain in interval notation is, now this is x is greater than or equal to 4. So we want to include this 4 in our domain. So if I were to put a 4 here, 3 times 4 is 12. 12 minus 12, I would get a 0, which is okay. We can plot 0. Square root of 0 is 0. So how do we say we're going to include that 4? Bracket. Right. So it's going to be 4 to infinity. All those values will work. Questions? How am I doing, America? Okay, so number 7, we do have a radical in number 7. However, also this radical is in our denominator. So this last one, we could say, all right, well, we can include 0 because the square root of 0 is just 0. Our problem is if we make our denominator, the square root of 0, 0, we're gonna have a 0 in our denominator. Undefined, can't graph it. So this one, we're gonna have to set x minus 9 equal to what? Just greater than 0, not greater than or equal to. So we have x greater than 9, and now we're not going to include the 9. Because if we put a 9 in there, 9 minus 9 is going to make at the square root of 0, which is 0, 4 over 0, can't graph it. So this is going to be from 9 to infinity, and we are out.